Hello, this is Professor Blackman. Welcome to Unit 8, Lesson 1. Today we're going to be talking about polynomial functions and models. We're going to briefly revisit polynomial vocabulary. We're going to look at in behavior. We're going to do some substitution to test for zeros. And then we're going to look at multiplicity of those zeros. So down here I have some the definition of what a polynomial function is. Usually it's, this could be n to the 3, then this is a 2 or 1, and going down to a constant. Or if it's a 4, then this is a 3, then this is a 2, 1. If this is a 2, then it's a 1, and then constant. You may skip some. If at any time a, the coefficient is 0, then you would go like 4, then 2. So we have quartic. That would be anything to the power of 4, which is a degree of 4. Cubic is whenever you see a power of 3, which means it has a degree of 3. Quadratic is to the second power, linear is x, and then constant is just a number, because there's always that understood x to the power of 0. All right, so let's go ahead and start looking at some in behavior. All right, so this is going to help us start to graph. And so I'm going to go ahead and give you some quick examples to kind of make this leading term test make sense. So we're going to talk a lot in this unit about odd functions and even functions. And odd is an odd number when your degree is odd, and an even function is when your degree is even. So let's say you have y equals x. Well, that's x to the 1, so that's odd. That looks like that. If you have y equals x squared, that's quadratic. It's going to look something like that. If you have y equals x to the third, it's a cubic function, looks something like that. And then y equals x to the fourth ends up, looking something similar to that. Well, if you notice with all of these, here we are starting in this lower left side and ending in this upper right side. For the even functions, we're starting up here and we're ending up here. We're starting up here and ending up here. And this is true for all odd functions, and this is true for all even functions. Now, if you look at our chart over here, it says when a is greater than 0. When a is greater than 0, that basically just means a is positive. Or when a is less than 0, it means our leading coefficient is negative. So if you compare our chart, we have this y equals x would be positive and odd. So this bottom left one. And even is here. So for me, my chart that I personally use, that I will draw, is I'll put odd here, even here. I'll put positive here, and I'll put negative here. So odd, we already have that, looks like this. Even looks like this. So these are the two examples that we've already done. Now, I didn't do any with negative, so let me quickly do a negative example. So let's say I use y equals negative x. Well, then that's just going to look like that. If I do y equals negative x squared, well, then we know that's going to look like that. So for negative, we're going to see it start here, end here, and we'll see it start here and end here. And then sometimes you'll see it where they do this to show we don't know what the middle looks like, but I typically just do the arrows myself. All right, so This is kind of a chart that you kind of want to have memorized. I highly recommend putting it into your notes and make sure you can be able to generate it. If you can't remember the chart, then just quickly graph y equals x squared, and then you can see where that in behavior begins and ends. All right. So let's look here. We can quickly see that this right here is negative. And we look at our powers. We have a power of 3, 1, 0. So this is an odd. So it's negative and odd. So negative and odd. Our in behavior is going to look like that. Negative and positive and odd would be this one. So this is positive, odd, negative, odd, positive, even, and negative, even. Okay, so again, here we know it's negative. So because we know it's negative, and now we look at the 6, we can tell it's negative and even. So this is positive and even. So it would be that one right there. All right, here, the 3.5, that's here. That 3.5 is a positive number, so we're going to say positive. And then that x to the 4, that's a quartic function right here. So that's an even function. So that's going to look very similar to x squared. So we have that right there. This 2/3, x to the 5th, 2/3 here is positive. X to the 5th, that 5 is odd. So this is a positive odd function. So that one's going to look just like C right here. All right, so that's a quick and easy way to help you determine your in behavior using that test. Okay, so now we're going to help figure out how we can determine if something is a 0. One way to do that is to take values that are given to you, plug them in, and substitute them, and then just see if f of x equals 0. If f of x equals 0, then x is a 0 of the function. All right, so let's go ahead and jump right in. All right, so let's start by plugging in 4. So we get f of 4 equals 4 to the 3rd minus 9 times 4 squared plus 14 times 4 plus 24. So 4 times 4 times 4, 64. 4 squared is 16 times 9 is 144. Plus 14 times 4 is 56. Plus 24. So 64 and 56 and 24 give you 144. Take that away, 144, and you end up with 0. So you just need to plug those in, see if it equals a 0. So 4 is in fact a 0. When we plug in f of 5, 5 to the 3rd power minus 9 times 5 squared plus 14 times 5 plus 24. So when we simplify that, we get 125 minus 225 plus 70 plus 24. Simplify that, you get minus 6. So 5 is not a 0 of the function. Now let's plug in -2. Make sure when you are plugging your negatives you are careful, so that way you are getting the right sign at the end. Alright, so this gives us -8. Negative times negative times negative. That is a positive 4 times 9, which will give us -36, minus 28, plus 24. And so this one has a bunch of negatives, so it's not going to equal 0. It equals -48. All right, so we had 4 being a 0, 5, and -2 not being zeros. All right, let's look at this example. So let's start with 2. So g of 2 is equal to 2 to the 4th minus 6 times 2 to the 3rd plus 8 times 2 squared plus 6 times 2 minus 9. 2, 2, 2, 2, and 2 give you 16, minus 6 times 8, which is 48, plus 8 times 4, which is 32, plus 6 times 2 is 12, minus 9. Simplify all that, and you get 3. Plug in 3 now, our 3 here, and we get 3 to the 4th minus 6 times 3 to the 3rd plus 8 times 3 squared plus 6 times 3 minus 9. All right, 3 times 3 is 9. 9 again is 81, minus 6 times 3 times 3 times 3 would be 6 times 27. And that will give you 162, plus 8 times 9, which is 72, plus 6 times 3, which is 18, minus 9. 162 and 9 are your negatives. Add 81, 72, and 18 together, and you will get those canceling each other out. And then let's do g of -1. To the 4th would be 1 minus -1, -1, -1, make it +1, so plus 6, 8 here, and 6 times -1 would be at -6, minus 9, and 1 and 8 cancel with this 9, 6 and that 6 cancel, and you end up with 0. All right, let's look at our next example. All right, so previously we were testing if zeros are, and now because of the zero product rule, we know when something's in factored form that we can make this a 0, because if this is set equal to 0, x plus 3 equals 0 and x minus 1 equals 0. We know from previous sections that of solving that these are the solutions, and when this is set equal to 0, these are also zeros of this polynomial function. So we get x minus 3 and x equals 1. We can always plug that back in. 1 minus 1, 0. 0 times anything, 0. Plug in -3. -3 plus 3 is 0. 0 squared times anything is 0. And then with these, we're also asked for their multiplicity. Multiplicity is very easy to figure out. Here, x minus 1 was only counted once, so this has a multiplicity of 1. This x minus 3 is counted twice because it's squared here, so this has a multiplicity of 2. Multiplicity makes graphing very interesting because let's say here you're seeing it's at -3, so I'll just quickly draw a graph. 1, 2, -3 is right there. When it has a multiplicity of 2, it doesn't cross through this point. It instead will either bounce off if it's come from the negative direction or bounce up. And so that's what the multiplicity shows you. You'll have this or that. With a multiplicity of 1, so, x equals 1 is right there, you cross through or cross through. And so that's just, it's going to make our graphing in future lessons a lot faster to understand this multiplicity. All right, so let's go over here and look at this one. We can take x minus 4, set it equal to 0, x plus 6, set it equal to 0. So x minus 4 becomes x equals 4, and x equals -6 when you subtract 6 from both sides. These are both odd multiplicities, so they'll both go through just like our second example on the problem 1. But this one has a multiplicity of 3 because of this exponent of 3, and this has a multiplicity of 1. But since they're both odd multiplicities, they will both cross through their x-intercepts. All right, let's look at our last page of examples. All right, so these are not factored. So first we're going to have to factor the polynomial. And as you can see, there are 4 terms here. So I recommend factoring by grouping. So group these, x squared is what they have in common. And that leaves a x plus 3. Leading term is negative. So we have an x plus 3. And if you don't remember how to do factoring by grouping, go ahead and see other videos with factoring by grouping. Now that your x plus 3's agree, we'll put that up in front, x plus 3, and then we have x squared minus 1. Well, this isn't an x plus or minus number. We have an x squared here. So always, if that ever happens, make sure you check to see if that can factor further. And because that's difference of squares, we know it can. So this is x plus 3. Difference of squares is x plus 1, x minus 1. And so we can set each one of these equal to 0. That gives me -3. X plus 1 equals 0. Gives me x equals -1. And x minus 1 equals 0 gives me x equals +1. And all of these have a multiplicity of 1 because there is no powers anywhere here. All right, let's look at our next example. Here, again, factoring by grouping. Group these two, and x squared, which will leave a 2x minus 1. Leading term is negative. Factor that out. Factor out of 4. -4 would leave 2x minus 1. Okay, so then f of x now becomes 2x minus 1 and x squared minus 4. And again, that's difference of squares again. Very common. 2x minus 1 and x plus 2, x minus 2. And as you see, all of these will have a multiplicity of 1. Set each factor equals 0 using the 0 factor. We get 2x equals 1, x equals 1/2, x plus 2 equals 0, x equals -2, x minus 2 equals 0, x equals 2. As you can see, all of these have a multiplicity of 1. All right, that's all I have for you today. Happy studying.